Hey everybody, what up? All right, so in this video, I'm going to be talking about just a web developer guide for 2022. What do I think about the technology that you need to learn? And it's really just going to be a mix mash of everything that I sort of see going on in the web development world these days. All right, so let's go ahead and talk about when it first comes down to writing code, what is everybody using? And really, it's still a mix of really Windows and Mac for the most part. So those are the machines that most people are using. Windows, I find to be much more frustrating experience being a developer for. But I've done that for a long time. And then for the last 3.5, 4 years or so, I've been using a Mac. And I was never a Mac person before that, but I'll tell you, like, Mac just works better than Windows. It just does. But if you're doing video gaming and things of that nature, if you're really a C#.NET shop, you're not going to be using a Mac. And that's where you end up having headaches if you're doing a Mac. So whether you're using Windows or Mac, it really doesn't matter. Linux, so I would say that there's probably less programmers that are just strictly writing all their code on Linux operating systems. I don't see that all that much, but I'm sure it exists. So let's talk about how do you write your code. So these days, everybody's using Visual Studio Code. It seems to be the most popular integrated development environment. Some people, I mean, I guess you wouldn't really call this it's not a text editor. It's a integrated development environment. It's free. It's open source. It's written with the same technology that's being used by Slack. And it's impressive. So it's a memory hog. It does sometimes have to be restarted, but there's like plugins and extensions for pretty much everything, and it doesn't cost any money. Now that said, a lot of web developers are also using Webstorm. So Webstorm, I feel like, has some better capabilities when it comes to like auto suggest. The tool adaption is a little bit slower, I think, just because it's a for-profit corporation that's doing this versus like a bunch of volunteer code. So they're both great products in my opinion. I actually use them both daily, so I don't really have a preference, but I do think that, you know, if money is tight, then definitely just stick with Visual Studio Code. It pretty much does everything you need. All right, the next thing is going to be everybody's using Node.js. So even if you're not actually writing a Node.js based website, you're still going to be using Node.js as your build tools. So that means that any sort of project that you're setting up, whether it's like React, Angular, whatever, most likely you're using Node and specifically NPM that comes with Node. You could also use Yarn, but NPM still seems to be the most popular, and that's really just a server essentially that is managing all the different packages that you need to install, and then the Node.js runtime allows you to build projects and keep track of your dependencies and all that. So I think Node is definitely a requirement for any web developer that's out there, even if you don't plan on using a Node.js web server like I mentioned, but you're still going to need it to compile your JavaScript and all that stuff. So how do you even compile it? Really, it's most people are using Webpack. There's a couple of other tools that have come out lately. I think Vite is one of them. Is it Vite? Yeah, I think it's Vite. I haven't used that yet, but it's really Webpack and Rollup are the two biggest ones, and Webpack is definitely the biggest when it comes to taking all the different modules, whether it's React, Angular, whatever, and then mashing it into one JavaScript file. It can also do other things like image loading. Webpack Dev Server allows you to do development. And essentially that is going to be a requirement to learn as well. The next thing is going to be everybody's using GitHub in one way, shape, or form. So I think it's important to have some sort of presence there to know how GitHub works. But specifically, GitHub is called GitHub because of Git. So Git is the version control system that everybody's using. The earlier you're able to pick up on a version control system, the better off you'll be. It keeps track of different changes so you don't try to blow away. You can still blow away your changes, but ultimately when you have a bunch of different developers working on a code base and we could be working on the same things at the same times, like how is all that managed? It's managed via Git. So Git is definitely a technology on its own that you need to learn. And then once you have that, though, you can use Bitbucket or GitHub or any of these other products for repositories. All right, the next thing to know is that most of your development testing should be done on Chrome. So everybody's using Chrome. I say everybody, it's like 80-some% of the market now at this point. And when we look at something like Firefox, they have like 5%. And then now you have like Brave and a couple of other browsers that are still out there, Safari, Internet Explorer still hanging around, Edge. But most people are using Chrome, and they're using it for a multitude of reasons. But there are extensions that you can use for everything. So if you're using a React Redux-based website, there's a Redux toolkit extension that you can install into your browser. There's also ones for React and Angular. Essentially, there's a lot of different extensions that you can use to customize your Chrome and allow you to debug a little easier. You can write your JavaScript right into the command line here. So hello JavaScript. So if you're doing any sort of quick testing with JS code, you also have something called your sources panel. This is very important because when you use source maps with a compiler tool like Typescript or even JavaScript that's being compiled to an older version, you use source maps in order to be able to step through and debug the actual code you wrote versus the code that you wrote that got compiled into a much different type, a much different looking JavaScript code. So what do I mean by that? It means that there are certain projects where you can target certain browsers. You can even use Webpack or even TypeScript really and target Internet Explorer 5, if you wanted to for some weird reason. Luckily though, Internet Explorer 11 was like the last crappy product from Microsoft, or really crappy product anyway. And that is dying off quickly. So for all the people that have had the hell of supporting Internet Explorer, I feel you, I've been there. But when it comes to browsers, I think Chrome definitely has the advantage. The network panel is going to allow you to test, or see all your little network requests, whether it's an image that's being loaded, JavaScript. You can see what's like bogging down your system. It also will track your post requests, your GET requests for things to your backend API. So when we talk about backend APIs, that brings me to my next point. So everything is pretty much microservices these days, it seems like. We used to have full stack monolith web applications using something like ASP.NET, where your front end code had like a template engine, like Razor template engine, then you had your back end server side code, and all that stuff had to be compiled and deployed all at one time. These days, though, everything is much more micro focused. So you could have a server that is handling just one specific portion. That server is hitting some other server, but ultimately how you're hitting those servers is you're not doing like full postbacks to the server. You're making asynchronous AJAX calls from your client-side browser using JavaScript or TypeScript, and you're making this asynchronous call. You're hitting something like AWS backend, Linode, my former sponsor, Microsoft Azure. These cloud products are important in web development because they allow companies to just simply pay the price, and there is a price. It's kind of expensive, but if you are trying to build like the next great thing, or if you have a lot of money and then you're really building a product that needs to stay up and and be available all the time, that's why companies are turning to AWS and Azure. They have pretty much all the support that you need. They're not easy to work with, in my opinion. There's a lot to learn with them, but and I say not easy only because there's just so much to learn. It's just a very, very large product, and you don't need like half of it for whatever it is that you're trying to build, depending on what it is. But ultimately, whatever it is that you're trying to build, there's going to be some sort of support from caching services like elasticity, just being able to like target certain geographic areas. My particular server for codehawk.com, which by the way you should check out if you're learning the code, this website is actually, it's running Node.js, but it's on one server. So far I haven't had to set it up in like multiple different geographic areas, but eventually that might end up being the case. I've sold this now in 40 plus countries. The next thing to know is that there's a lot of popular web frameworks that are out there that are coming out for specifically like the Node.js runtime. Something like Next.js is very popular, using React-based architecture and having server-side rendering. So what does that even mean? A lot of these client-side code that we're writing these days with Angular, React, Vue, those traditionally have not worked all that well with search engine optimization. Search engines used to just be able to hit your website, get a bunch of HTML, parse that out, try to figure out what your website was about. These days, every website is loading. They're doing lazy loading. Sometimes the loading is only occurring on components as you scroll it into view. So for instance, maybe this component down here didn't even load on the initial page load. But with lazy loading, we scroll it down into the viewport, then requests are made. So how well is the search engines handling that? Who knows? I think Google search sucks these days, so I don't think that they're doing it all that well. If you're a full stack developer, which this is really targeted for full stack web development, what does that mean? Client side is front end. That is everything that's going on in your browser. If you're hitting a server somewhere, getting a database, hitting a database, or getting data, hitting a database, then that is your server side. If you're doing all of the above, then that's full stack. So when we're talking about full stack, one of the things is like if you're going to build a website, you got to have a domain name. So where do you buy it? You could buy it from all kinds of different areas. I'm not a big fan of GoDaddy. In fact, I sort of hate them. But I do use them for decades now, or over a decade, that I use them for all my domain purchases. They just do it really well. I buy the domain, I forward it to my Linode name servers, doing DNS management, and then that's the extent of what I do with GoDaddy. So I'm just paying them every month just for my domains, and I have like 20 of them. When it comes to writing client-side code, everything is also these days like component-driven. So if you're going to be using a component library, React is the most popular. That takes quite a bit of a learning curve, as well as Angular. They each have their own way of doing this, but it's all about building reusable web components in your browser, your user interface, and those communicate with your server. Vue.js is probably a third. Svelte seems to be gaining more and more traction these past couple years. And then a new kid on the block is like Solid.js. So these are all component-based libraries used for building out your front end. When it comes to the most popular front-end languages, JavaScript is probably still king. This is a language that's been around for a long time. It was originally created in 10 days. And it sort of shows over the years as far as like how it's written and some of the weird things that it did, not being lexically scoped and all that. Some people would call that a feature now, but the bottom line is JavaScript is still king. So if you're writing a web page, JavaScript is a necessary thing, and it's probably going to be a requirement anyway. So that's why Node.js is popular as a server-side stack, because even though it's not fully JavaScript that runs in the browser, you're writing JavaScript to interact with the runtime. And if you already know JavaScript, then you can jump into that versus having to pick up C# and start doing ASP.NET or Java with Swift, or not Swift, but with Spring. Or Python and Django or something like that. So instead of having to learn a separate server-side language, you could just simply do everything with JavaScript these days because of Node. Now, that said, JavaScript is typically being written by Typescript these days. So Typescript is a preprocessor language, which means that you're writing in Typescript. It provides statically typed, it's type safe. And then what that ends up doing is you compile it to just regular JavaScript. Use tools to bundle it all together. There's a bunch of plugins and everything. And then you just write less buggy JavaScript code, or at least that's the promise. It is a bit more verbose, and there's obviously a learning curve with that as well. But I would say, like, if I had to choose between the two, I mean, you might as well just jump into TypeScript because it is going to be something you run into. All right, when it comes to unit testing your client-side code or even your server-side code, there's a lot of different unit testing libraries that are out there. If you're using React, Jest is very popular. It was created by the Facebook people. There's most likely going to be some sort of an assertion library. And a lot of the, like, we used to use Mocha a lot for, or Mocha or Chai for the assertion library, I believe. But anyway, these days, though, the testing library project is the most popular because testing library has basically solidified all of the different unit testing tools that we used to use in web development, and there's basically extensions in the testing library for Jest and a bunch of other stuff. When you're dealing with databases, you could still use traditional SQL, so things like MySQL, Postgres, those are still popular tools, SQL Server and the .NET environment. But NoSQL is still something that is gaining wide adoption, and MongoDB comes to mind first, in my opinion. They're also a former sponsor, and they allow you to have unstructured code, so you don't have to do a bunch of database migrations and all this stuff every time you change your tables, like we're commonly doing in SQL relational databases. MongoDB just has a little bit more flexibility and freedom, but that said, some people say it's just not as reliable. You can be the decider on that, but I think when it comes to the learning curve, MongoDB is much easier to get up and running than something like Postgres or MySQL. Now, there's also competitor products too. So if you're using an Azure environment, Azure Cosmos DB is basically Microsoft's version of MongoDB that runs in the Azure cloud, and then DynamoDB is the same thing for Amazon and AWS. So a lot of companies are using this. Point being, NoSQL is pretty popular, but then you could also use a traditional SQL database as well if you want. All right, some of the other things that you need to know is web accessibility is an important thing. So web accessibility means that people that are blind can actually use your website with something like a screen reader. Is your website parsable? I mean, can you actually use your website? If you're big enough, you can actually be sued these days. Netflix got sued for not providing closed caption, and that's why they have that now. Domino's Pizza they lost a big Supreme Court case because their website was not usable. So if you're large enough, you can be sued for not having an accessible website. So where do you learn about these accessibilities that you need to do? this w3.org website is a good place to go, but it also includes just putting certain attributes on your elements to display like what it actually does, whether it's tabs or images. Having an alt text on your image is important. So yeah, anyway, web accessibility is a big deal. And then if you want, there's a Lighthouse. It's already built into Chrome by default, but you can like generate a report here. So this is analyzing MongoDB's website for accessibility. It'll give you a bunch of different feedback. This used to be like a separate product, basically a website that Google owned that you could analyze your website, but it's built right into Chrome now. So the tool actually crashed when I tried to run it on MongoDB's website, but you can see if I'm running this on CodeHawk, I got some decent performance here. I'm using Nest.js as a server-side stack, but I do a lot of my own custom sort of caching and stuff to try to get the performance up there, especially because I'm streaming hundreds of videos to thousands of people. Now my accessibility though is only a 73, so there's some work that needs to be done here, but this gives you a whole list of things that you can do to improve your website. The next thing to mention is user experience. So this is where the designs come in, what colors. I mean, this website used to be really popular when it came to user experience, but I sort of think this is ugly as hell and sort of childish looking. But that said, like user experience is a big deal. Like, do you use curved buttons? What colors do you use? Gradients? How large should something be? Like, there's a lot of different things you got to take into consideration. All right, so the next thing to consider is mobile apps. So does your website work on a mobile app? Because you could end up, you could write a separate mobile app and have it in the App Store, and that's good, but then you have to learn like Android or Kotlin or Swift or something like that. But these days, though, it's all about responsive web development. That's been around since about 2012. And it's about using something called CSS media queries so that you can see I'm like changing the device. What does my website look like on these different devices? You can see the behavior changes, the way things stack. And, this is all custom code that I wrote myself actually, and completely custom CSS using Sass. And that's another thing I'll mention in just a second. But that said, responsive web design, does your website work in the different size browsers? You could put this on responsive mode and then start stretching it. You can see that there's like some tablet issues there that I have. So you could work on that all day long. It's always a constant battle, but even the navigation works a little bit different. There should probably be some sort of slide out animation. Again, there's only so much time in the day. So next thing to talk about is how do you write your CSS? So Sass is a popular tool. We used to use Less, but then Less pretty much got replaced by Sass when it came to the Bootstrap project. And therefore, we're using a lot of Sass to write our CSS. It just makes it easier to write CSS. But now there's other tools that are coming out like Tailwind, which I hate personally, but it's a completely different way of writing CSS, so you don't have to do context switching. But you're basically having to relearn class names for CS, where we used to have just CSS selectors. So I find it kind of annoying, but some people do like it. So I'm not going to continue to bust on it. But the point being is that we're using tools to write our Sass. All right, the next thing to mention is that we're using component CSS. So this is a library that's called MUI. I'll mention that in just a second. But we're actually writing CSS in different ways. We're embedding it now in the components so that instead of running into CSS clashes and having to be very specific with our selectors, we're like basically going back to inline styling and we're putting it right into the components. So therefore, there's really no side effects, and that's basically the goal and the idea there. But learning component CSS, there's different ways of doing it, whether it's importing CSS like styles and classes or this inline approach. But we are sort of changing how we're building our user interfaces these days. All right, when it comes to component libraries that are already built for you, basically something like Bootstrap has been popular for a long time. This actually comes with a bunch of different types of components, and it deals with the styling for you. So here's like a pricing page. If you just want to bring this in, you see that this is commonly used. But if you use something like this, you could just bring it in as a component, and Bootstrap provides its own classes and stuff like that. So there's a lot of different projects out there that you can just simply copy and paste, and if you're using Bootstrap, it'll work. This provides the responsive mobile navigation and desktop that shrinks down to the mobile. So you can save yourself a lot of time if you're going to tap into one of these libraries. I mentioned Bootstrap first because it's been the most popular for the longest time, but it's sort of getting replaced these days. Something like MUI is a very popular alternative. You can see it actually looks a little bit better. It has more dynamic and I would say complicated components already built for you, but it doesn't mean that you avoid all complication. It's actually its own learning curve. But a lot of companies are adopting that because if you're able to tap into this, then there's a lot of CSS, web accessibility, user experience, all that stuff you don't have to really think about as much. And as long as you can just bring in the components. All right, the next thing to mention is that when you're dealing with the single page apps that we're commonly dealing with these days, we're using tools like React Router DOM, and the browser is not handling navigation anymore. It's actually done JavaScript code using projects, and we're hitting up these backend microservices with asynchronous AJAX calls. How do you deal with security in that situation? Like, how do you authenticate and verify somebody's able to see what they're able to see? A JSON web token is actually a very popular option these days. So you could store the JSON web token in local storage or session storage or in a cookie. My CodeHawk website is actually using JSON web tokens. And if you look inside like my cookies, I'm storing it in a cookie. I'll probably end up moving away from that eventually, but there's tokens that are being passed around so I can figure out who you are you authenticated? Are you a paying customer? Is your session still valid? So that is its own learning curve as well, but JSON web tokens are a really good option when it comes to modern day websites for authentication. All right, we have something called containers these days. Docker is really popular. Why? Because there's so much configuration that needs to be done in order for applications to work. Do you have the proper environment variable set and all this? Do you have the proper things installed? Are you running on a Windows or Mac or Linux? Or a different version of Mac or a different version of operating system for Linux? There's so many different possibilities, and it's a real headache trying to get everybody on the same page. So the idea with Docker is you can create essentially a virtual machine, and it's not exactly a virtual machine, but it's very similar. Less overhead really than a traditional virtual machine when it comes to the kernel and all that. Docker itself, though, does run in a virtual machine, so it is still considered one. But you end up building these containers, and they create all those environment configs and everything for you. And therefore, if you just simply have Docker installed and you import your container or run your container, then everything is just simply going to work. So Docker is very popular when it comes to containerization of runtimes that we commonly use in web development and really all of development these days. And then when it comes to managing all those containers, deploying them and everything, that's where Kubernetes comes in. This is a product by Google, but essentially it's allowing for the deployment, scaling, and just management of those containers. So if you're using something like Docker, it helps you manage all that, assuming you have a bunch of different Docker containers. All right, so the browsers are continuing to get better. We're still dealing with the same static content. So whether it's like a movie file, MP4, image files, PNGs, JPEGs, GIF, WebP is a new image format. So I'm actually using this on CodeHawk. I say new, but it came out 11 years ago, but people weren't really adopting it until recently because of the browser support that needed to be there. But it gives you transparent images similar to a PNG where a JPEG does not, but it's like half the size or like a third of the size of a typical PNG with about the same amount of quality. So it just simply speeds up your website a great deal. I was able to speed up CodeHawk by like twice as fast just by simply using WebP for loading images. All right, so the browsers are getting better and faster these days with JavaScript. It runs much faster in the browser than ever it used to. A project like Three.js has been around for a long time, but we can do some pretty cool stuff. So like, I was hoping this example would be better than this. This is a video. God dang it. Anyway, so I was trying to show you that Three.js has the ability to load 3D models and Jesus. All right, cool. Here's an example of what I was looking for. So this is taking 3D modeling. It's still slightly, I think a little buggy, but I'm sitting here, I'm rotating it with my mouse. So how can we end up taking websites to the next level? We really need to have like 3D, virtual reality, augmented reality, The browsers are slowly getting better and better with that, but we're running into a situation where JavaScript is just simply not fast enough. So the new kid on the block, and this is a development effort from a lot of major companies, from Adobe, Google, Microsoft, Apple, they're all working together on this WebAssembly language. So WebAssembly has only 4 types. They're all numeric types. And you don't really write in WebAssembly itself, but you can use something like the Rust programming language or even Python these days. But Rust is probably the most popular one when it comes to writing Wasm. Wasm is the compiled runtime code for WebAssembly. So where does this fit in? WebAssembly is essentially promising that, especially once it starts working with the DOM, which is very limited in the ability to like inject DOM elements into the browser like JavaScript can do. But once it's there, then there's a possibility that we could be writing our web-based applications in languages like C# or Python or Rust or Go, something other than JavaScript or TypeScript. And TypeScript itself does not run in the browser either, so that has to be compiled. But eventually what's going to happen when we're building all of our apps and you write it in Rust and you compile it to Wasm and then run that in the browser, it gives you basically half the speed of native C++, which is roughly like, I think 3 times faster than JavaScript right now, or maybe more. So that will end up opening up the possibility of having virtual reality, augmented reality, and have that be a little bit less buggy inside of our browsers. And, who knows what sort of doors that's going to open as well. All right, the next thing to talk about is web servers. So one of the most popular web servers out there is Nginx. I'm using this for my CodeHawk website as well. I use it for loading static content. So any of the images, JavaScript files, CSS, it all gets rendered via Nginx because it does it well. I use Apache still because I don't really know actually why I'm using Apache, but I just sort of did that initially, and it's still sort of in there as legacy code. But I used to allow for the downloads of the videos, and I did that on a separate process, separate server, and I had Apache set up to handle that, and it still does. But Apache is still very, very widely used, and it's probably the most widely used server out there. But there are other servers as well. So something like SQL Server is a popular option for .NET shops in Microsoft. And then these days, a lot of servers, this stuff is a lot of this stuff is cloud-based and set up for you. All right, the next thing I'll mention is single SPA. This is a new sort of architectural pattern that's coming up. There's also federated modules with Webpack. But what it is essentially each little component is going to be its own separate application. And instead of bringing a bunch of different components into one application, you essentially have each component be its own application with its own API. And it's considered to be a front-end microservice. So that means like your navigation down here could like be making AJAX calls itself and be completely self-contained and not have anything to do with any of these other components. So if one component fails, the entire page doesn't break. That's also something called error boundaries in React. But it's a problem when you have apps that have a bunch of different components with a lot of JavaScript. Something can go wrong. It breaks the entire application. Breaking it up into reusable components allows you to not have to build a monolith web application. So monoliths, everything has to be deployed all at once and working all at once. But when you break up things into microservices, micro front ends, it allows you to essentially build something in isolation and deliver that whenever you need to. Now, that also said, when you start doing something like that, you probably need a tool like feature flagging. So Split.io is a popular tool for feature flagging. That basically is just a Boolean that says, hey, if this feature is turned on, deliver this component versus some other component. And it just allows teams to develop, again, in isolation, quicker, bring everything in as it's needed versus all at one time. So I know there's a ton of information, but if you are learning, check out the website because most of this stuff is actually covered in one way, shape, or form, or will be soon. But it gets you up and running at the very least for very cheap. If you're learning to code, I recommend you check out my website, codehawk.com. My courses are fast, to the point, without the fluff that you'll find on other competitor sites like Pluralsight and Udemy. One of the reasons why you'll want to learn with me is that I'm a self-taught engineer myself. I never went to school for any of this stuff. I've been doing it for over a decade now professionally. The biggest reason you should use CodeHawk is that it's one price for everything. I try to make this as affordable as possible. Instead of having to purchase 15 to 20 different courses on Udemy or an expensive monthly subscription to Pluralsight, It's one price for everything on CodeHawk. Front end, back end, full stack. It has courses on all the latest web development technology. The courses range from beginner to advanced. So if you want to learn the latest web technology, give CodeHawk a look. There's demos for all of the courses that are out there right now. In addition, there's also my personal vlogs, which I'll be adding more to. So content that I don't release to YouTube is available on CodeHawk.